in this video, we will be discussing about word subsets. You are given two string arrays, words1 and words2. A string B is a subset of string A if every letter in B occurs in A, including multiplicity. A string A from words1 is universal if for every string B in words2, B is a subset of A. Return an array of all the universal strings in words1. You may return the answer in any order. So what they are saying is that in the input, we are given two string arrays, words1 and words2, right? Now, they are telling that a string B is a subset of string A if every letter in B occurs in A, including its multiplicity. So basically, if let us suppose that one of my strings is warrior and another string is WRR, right? Now, this string will be a subset of warrior if warrior contains all of these letters, including their multiplicity. Basically, here we have one W, right? So this string should have at least one W present. So yes, it has. Then we have two R's over here. So this string should have at least two R's. So we have here. So we can say that this string is a subset of warrior, right? Now these R's don't have to be necessarily present together. We can also consider this one R and this one R, right? So basically order does not matter. It's just that whatsoever frequency of that character is there in this particular string, this string should have at least that frequency present for that particular word, right? So this will be a subset of this string, right? Now what we need to do is in the words1, if let us suppose that I take a string, right? Now if all the strings in words2 are a subset of this particular string, then I will say that this string is universal and I will include it in my answer, right? So we need to find all such strings, and wherever all of the strings in words2 are a subset of that particular string in words1, then we have to put it in our answer vector and we need to return it, right? So if we see here we have Amazon. So first is E. Do we have an E inside this string? No. So this won't be a universal string. Then we have Apple. Do we have E? Yes, we have over here. Do we have O? No, we don't have. So this is also not universal. Then we have Facebook. So now here, do we have an E? Yes, we have over here. Do we have an O? Yes, we have. Do we have two O's? Yes, we have two O's. Do we have one E? Yes, we have one E. So all of these strings are a subset of Facebook, right? So this is a universal string, right? It will be included in our answer. Then we have Google. So is E present in Google? Yes. Is O present in Google? Yes. Is O present two times in Google? Yes. Is E present one time in Google? Yes. So it is at least one time, right? So all of these strings are a subset of Google. So this is also a universal string. Then if we check for Leetcode, is there at least one E present? Yes. Is there at least one O present? Yes. Are there at least two O's present? No. Right. So this is also not universal. So our answer is an array containing these two strings, which are the universal strings, and this we need to return. Right. So now how to solve this? So now our naive approach would be that we will take each of the strings from words1, right? And then for each of the string in words1, I will iterate for all the strings in words2 and I will check whether all of these are a subset of that particular string or not. If it is, I will push it in my answer. Otherwise, I'll move on to the next string, right? So as I said, for each of the string, you will iterate in all the strings in words2, right? So if I say that the length of words1 is n and that of words2 is m. So basically, first you will be running a for loop n times and then you will be running a for loop m times, right? And then you will fix each of the string in words1 and then check whether all these strings are a subset of that particular string or not, right? So basically, first you would be running a for loop n times and then inside that for each of the word, you will be running a for loop m times, right? So it will be n cross m, right? And then inside that, you would also be checking if this particular string is a subset of this string or not, right? So how are you going to check that? So if let us suppose I need to check for these two, right? So first string is Amazon. Inside this, A is coming two times, M is coming one time, Z is coming one time, O one time, N one time, right? And this string is E. Next string is E. Here E is coming one time, right? So now we need to check that does Amazon contains at least one E. So we check it doesn't have any E, right? So this string is not a subset of Amazon, right? So we can skip Amazon and we can move to the next string, right? So if we take an example of warrior again, so if the string is warrior, right? So here W one time, A one time, R three times, I one time, and O one time. And the next string was WRR. So here W one time and R two times, right? So now warrior should have at least one W. Does it have? Yes, it has. Then it should have at least two R's. Does it have? Yes, it has. It has three. As I said, at least two should be there. So it is having. So we can say that yes, WRR is a subset of warrior, right? So basically, you can create a hash map or a vector of length 26 for storing these counts, right? In the question, it is mentioned that each of the strings will have letters from A to Z, right? So these are total 26. So you can create a vector of length 26, right? In that, 0th index will denote the frequency of A, first index will denote the frequency of B, and so on. And 25th index will give you the frequency of Z, right? And with that vectors, you can find out whether at least one W is present here or not, at least two R is present here or not, right? So basically, here first you ran a for loop n times. Inside that, for each word, you ran a for loop m times. And then you would also be iterating for each of the characters in this string also, and each of the characters in this string also, right? The maximum length of an individual word can be 10. So it will be into 10. So this will be your time complexity for this approach, right? Now, this n can at max be 10 to the power 4 and m can also be at max 10 to the power 4. So this is not going to work. We will have to optimize it, right? So see, we are doing some extra work over here. If you see, for each of the words, I am again and again iterating for each words in words 2 and finding out their frequency count and checking whether they are a subset of this string or not, right? So I can eliminate this part, right? Instead of doing this part n times, I can do it just once. I can pre-compute it, right? So how are we going to pre-compute it? So see, for each of the words, what am I doing? I am finding out the frequency vector for all these strings, right? So frequency vector for the first string will be E is needed at least once, O needed at least once. In this, O needed at least two times, E needed at least one time, right? So can I combine these together? If I will keep them separate, I will again have to iterate m times. So what I will do is I will combine them. Why I will combine them? You will see. So see, if I combine them, so E here is needed at least one time and here also it is needed at least one time. So I can say that overall my string should contain E at least one time, right? Then here O is needed one time and here O is needed two times, right? So I will take the max of these two. So max is 2. So I will say that if in my string O is present two times, then it is satisfying for this string also and it is satisfying for this string also, because 1 means at least 1. So if it has 2, then it will work for this string also. But here 2, at least 2 is needed. So that is why I have taken 2 over here. So now when you have combined this, now you have just one vector of length 26, right? And then for each of the words in words 1, you can compare their frequency map with this frequency map just once, right? And you will be able to get your answer, right? So for example, if you are at this string Google, right? So you will create its frequency map. So G will be 2, O will be 2, L will be 1, E will be 1, right? So you will check, is it having E at least once? Yes, it is having. So this and this is satisfied. Then it should have O at least two times. Is it having O at least two times? Yes. So now this and this is also satisfied. All of these are satisfied. So we can say this is a universal string, right? Same thing we can do for all of the strings. So now we have reduced our time complexity. First, you will be building this vector of length 26, right? For this, you will be iterating for each of the words in words 2, right? And then in each word, you will be iterating for all the characters in it, right? So basically this will take m into 10 times, right? And then for identifying whether a string is universal or not, you will run a for loop n times. Inside that, you will run a for loop for each of the characters in words 1, right? So that will take n into 10 times. So we can say that the time complexity will be n into 10 plus m into 10, right? So we have reduced it. right? So space complexity we will see after writing the code. So this is the approach. Let's code it out. So first of all, let's create an answer vector which will store our universal strings. Then we'll create another vector which will be the frequency vector that will store the combined frequencies of all the words in words 2, right? So let's name it words 2 max, right? Its size will be 26 and initially all the frequencies will be 0. Then we will run a for loop that for string word in words 2, right? Now for each of the word, we need to find out that what is the frequency of each of the character in this particular word. So we will create another vector, let's suppose count, its size will be 26 and all the frequencies will be 0 initially. Then we'll run a for loop for each of the character in word and we will update its frequency in the count vector. So in the count vector at the index ch minus a, we will increment it by 1. So after this for loop in the count vector, you will be having the frequency of all the characters in this particular word, which is present in words 2, right? Now we need to update this in the words 2 max, right? So we will run a for loop of I starting from 0 going till 26, we'll do I plus plus, and inside this in words 2 max at index I, we will store the maximum of whatever it is having right now and the count, right? Whatever is the maximum frequency for each of the character that we will store in this particular vector, right? So now we are done with our pre-computation. Now we will identify our universal strings, right? So we will run a for loop for string word in words 1, right? Now again, we need to do the same thing. We need to count the frequency of all the characters in the word, right? So once we have counted, now we need to check whether this word is universal or not, right? So we will create a boolean variable is universal. Initially, we will keep it as true. Now we will run a for loop of I starting from 0 going till 26 and I plus plus, right? Now, as I said that whatever is the frequency of a particular character in words 2 max, that should be less than equals to whatever is the frequency of that character in this word, right? If this is true, basically this condition has to be satisfied, right? So if in any case this condition is not satisfied, basically words 2 max of I is greater than count of I, then it is not a subset. So in that case, we will update is universal to false and we will break out of this loop, right? And once we have come out of this loop, we can check that if our string is still universal, then in the answer, we will push back the word and in the end, we can return this answer, right? So this is what our code looks like. Now here, we are running a for loop in words 2. So it will be running m times. Then for each of the character in word. So this can at max run 10 times and this will run 26 times, right? This 26 and 10 are constant. So we'll only say this is running m times. Then here this loop is running for all the words in words 1. So this will be running n times. And here it is running for each of the characters. This can at max go to 10. Here it is running 26 times, right? So we can say that the overall time complexity of this code will be n plus m. Coming towards the space complexity, here we have taken a vector whose length is 26. This is our answer vector, this won't be included. Then here again another vector of length 26. Here again another vector of length 26, right? So we can say that the space complexity over here is order of 26. Let's try to run this. So the test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.